Hello class, this is lesson 6-5 titled How to Use Proportionality Theorems. Okay, so now we have different theorems based on things that might be proportional. So our first theorem that we're going to begin with is theorem 6.4 titled the Triangle Proportionality Theorem. And what it says is that if a line parallel to one side of a triangle intersects the other two sides, then it's going to divide the two sides proportionally. Okay, so this line TU, because it's parallel with one of the sides, it is dividing this side proportionally to this side. So what I could write is if TU is parallel to QS, then the proportion RT to TQ is going to be the same as the proportion RU to US when I write down the lengths of those different segments. Okay. Our second theorem is kind of similar. This is the converse of the triangle proportionality theorem, and this is theorem 6.5, and what it says is that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So this time I'm told that these segments are proportional because of this line splitting them, and because of that I can conclude that the two lines themselves are parallel. So I'm going to write if RT to TQ is equal to RU to US, then I can conclude that TU is parallel to QS. Okay? Awesome. The last thing that I want us to realize is that this is implying something very specific. It's implying that if RT to TQ is not equal to RU over US, then the two lines themselves are not parallel. And vice versa. If we find that the two lines are not parallel, then they are not going to be proportional either when I'm looking at their sides. So why don't we do a couple examples based on these theorems, okay? Our first example says that RS is parallel to PN, okay? So these are two lines. One is inside the triangle, one is at the base, and I'm given three of the segment lengths. I'm given MS is 15, RP is 12, and also SN is 20. And I want to find that other length, MR. So the way that we're going to do this is we're going to just set up a proportion, okay? So when we're writing this proportion, it's important for you to write two things that are on the same side, okay? Because it's that one side that's being split up. So 15 over 20 is what I'm going to write. And then I can set that equal to the other side and how it's divided up. So MR is what I'm looking for over 12, okay? So then, just like any other proportion, we're just going to solve it. So I'm going to multiply by cross-canceling. So I'm going to get 180 is equal to 20 times the MR. And when you divide both sides by 20, we're going to find that MR is 9. So I found the missing length. Awesome. Let's go ahead and do another example. This one asks us to determine whether PS is parallel to QR, okay? And so this comes from the converse, that if the sides are proportional, then we can conclude that the two lines are parallel. So let's go ahead and write our proportion. I want to compare QP to PN because they're both on the same side. And I want to see, I'm going to put a question mark, if this is going to be equal to RS compared to SN. It's really important that you write these in the correct order and you don't mix them up. So now I'm just going to fill in what I know. So QP is 50 over 90. And is that the same as 40 over 72? Well, on this side, I can divide both of them by 10, so I'm going to get 5/9. And this side, I can divide them both by 8, and I'm going to get 5/9 as well. So because of that, yes, PS is parallel to QR. And I'm done. Okay? Awesome. So let's move on. I have a couple more theorems to share with you. Our next is titled Theorem 6.6, and it says if three parallel lines, okay, so I have three lines that are parallel, if they intersect not just one transversal but two transversals, then they're going to divide the transversals proportionally. Okay, so they're dividing the transversals proportionally. So I can say then that UW compared to WY, because I want to stay on the same section that's just being divided up, should be equal to VX over XZ. Okay, this is basically what this theorem is telling us. So it's kind of a cool fact. Pretty short theorem. Then our other theorem says, for 6.7, it says, if a ray bisects an angle of a triangle, okay, so I have this ray coming out and it's bisecting this angle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay? So what that's telling me is that AD, that this segment right here, if I compare that to DB, then that should be the same as comparing AC to BC. And you're going to get the same proportion, the same ratio. All right. So to close this out, I have two examples related to both of these. The first one is asking us to find the length of AB. Okay. And as you can tell in this diagram, because these lines are meeting this bottom transversal at 90 degrees, that's telling me that all three of those lines are parallel to one another. Okay, so even though it didn't specifically say it, I know from the diagram that they are parallel. So we just need to write our proportion. And so I'm going to compare 16 compared to, if I'm looking for AB, I'm going to call that X. And this should be equal to 15 over 18. Okay, so I'm going to do some cross multiplying. 16 times 18 is 288. On the other side I have 15x. And then when you divide both sides by 15, we're going to find that x is equal to 19.2. So it's okay if you get not a complete number. If you have a partial number like a decimal or fraction, that's totally fine, because we know that you can always measure lengths with partiality. So here we go. Last part. One more example. We're told that angle QRT is congruent to SRT. So we're told that this is bisecting this top angle R. And then we're asked just to find the length of TS. Okay. So this is a little difficult because I only know this entire length from Q to S. And I'm looking for just part of it. So what we're going to do is we're going to compare different sections by saying that if this is X, then I can say that this right here is 40 minus X. Okay? And so then I'm going to write my proportions. So I'm going to say that 40 minus X compared to X, so I'm doing the left compared to the right, should be equal to the left side, which is 24, compared to the right side, which is 32. Okay, so it looks a little bit messy, but don't worry. I'm going to simplify this fraction right here first. So 40 minus x divided by x is equal to, if I divide them both by 8, I'm going to get 3/4. Now I can do some cross multiplying. Okay, so on this side I'm going to have 4 times 40 minus x, and the other side I'm going to have 3x. This gives me 160 minus 4x equal to 3x. If I add 4 on both sides, I have 160 equals 7x. And then when I divide both sides by 7, I'm going to end up with x being equal to 22 6/7. And there you go. So we're done. So I hope that this was pretty straightforward for you. You have great examples here. There's even more in the book if you need extra assistance, but we'll come to class and get to work. See you then.